तो कैमरा तो ऑन ही रहता है।
हाँ, आपका वो माइक भी ऑन है।
हाँ,
एक बार अपना स्लाइड जरा शेयर करके दिखाइए।
एक मिनट भाई, ये मास्क खोल दूं। हाँ तो
4 मिनट है वैसे।
हाँ, कोई बात नहीं, आप चाहें तो शुरू कर दे, मैं तो सीट पे ही हूँ।
नहीं, ऐसा तो हमारे रोज ही है ना, 5 बजे।
हाँ,
वो 12 बजे आएंगे।
अच्छा अच्छा, तो ठीक है, वेट कर लेते हैं 4 मिनट। थैंक यू। हेलो, हाँ हो गया।
Very good afternoon, everyone. I welcome back to the 4th day of second session in 5 days faculty development program in additive manufacturing and industrial scopes and applications. Now, the session title is Additive Manufacturing, 3D Printing Technology, Market Scenario and Their Applications by Mr. Vinod Pandey. I would like to introduce about Mr. Vinod Pandey from Adroitec, Noida. Vinod Pandey has been working in the area of additive manufacturing, that is 3D printing, CAD, CAM, CNC, has over 20 years of work experience, which includes 12 years experience in 3D printer, additive manufacturing and information technology. Currently leads the 3D printing business with MS Adroitec Information Systems Private Limited. He has been involved in 3D printing, ramping and stabilizing new cutting edge technology business in the country. These include E2E business modeling and go to market designing, and also includes contributing and conducting training of 3D printing, additive manufacturing and reverse engineering and design, etc. He had a humble start in 1998 as computer software professional and CAD/CAM designer at UNPD project to develop the micro entrepreneurs. After UNDP, he has engaged to promote with some global brand as Mitsubishi, OBJET, Roland, Mark Forged, Exact Metal, Instinct, etc. Currently, he is in HP 3D printing and digital manufacturing business. A strong believer of blue ocean strategy and possesses good skills to connect dots, thus forecast business shifts. Mentoring and helping youth and professionals in his passion and humble way to contribute back to the society. I am very much happy to welcome you, sir.
Sir, please unmute yourself, sir. Your mic is mute.
Hello.
Yes, sir. Now it's audible.
So now it's audible. But when I okay, so we can start now. So thank you, thank you, thanks for you give us opportunity to interact with you for this is a faculty development program. So basically, we are from Adroitec, and 4DS is our brand. So 3D printing business we are dealing under the flag of the 4DS. So Adroitec is a 30 years old company, and they have a 4 groups. So 4DS is basically dedicated for the 3D printing technology. So we have a more than 10,000 man's year experience, pioneer in CAD/CAM. Basically, people when they just worked on the manual drawing, that time Adroitec brings the Autodex in India. So this is our company profile. So we are basically too much on the engineering side only.
Second date is
जल्दी करना आधे घंटे 1 घंटे में नहीं 1 घंटे में खत्म हो जाए मैं दे रहा हूँ सर हेलो यस सर सॉरी Adroitec information system actually the delivering the technology is the MC SDC service, Geomagic and ACE solution, additive manufacturing and product distribution. So almost all engineering kinds of solution we having with the or all Adroitec groups. So just I am giving the very some our company profile. So what is the 3D printing? I think so you all are in the engineer and know what is the 3D printing. But I like to give some view like 3D printing is a process of making a 3-dimensional solid object of the virtual any shape from the digital model. 3DP uses an additive process where a material are applied in successive layer, and 3D printing is a distinguishment from the traditional subtractive machine technique. So this is basically in the 3D printing. Just I will giving the overview. So just I am coming the technology called HP multi-jet fusion technology. So basically the people just hear about the or know about the 3D printing. They just they just have a mind. This is a for prototype only. But nowadays, the 3D printing is not for the prototype. 3D printing is using by the industry for the completely as a production part as comparable with the injected molded solution part in the terms of the plastic and metal both. So HP bring the technology for the complete manufacturing series, and they have a very good presence in market within a very shorter time. They also acceptability of the industry. So why HP actually the catering the production series market, because of the functional part, and HP technology is the 10 times faster as comparable to any technology which can produce the more part as compared to the any 3D printing technology, and at the lowest cost of the material, and the per part cost is the lowest as per any 3D printing technology. So this is a basically key point of the HP 3D printing technology. So HP Jet Fusion 3D printing solution have a software and plugin, command center, a printing station. This is you see my cursor. This is a HP written there. This is a printing station. 3D printer. Actually, this is a 3D printer, and we have a build unit. So build unit there filled the powder, polymer powder, and you see this one is a post processing unit. So this is a unique combination of the printing. So this 3D printer can use 24 into 7. After print the one build, then you can insert the another build, and this printed build you can insert here the post processing fast cooling, and it can be done manually within the very few hours. So most common misconception about the multi-jet fusion. People think this is a binder jet, and some people think this is a material jet. Actually, binder jet and material jet just using in the industry for the only for the prototyping segment. So HP multi-jet fusion technology is not a binder jet and also not a material jetting. This is a completely is a fusion jet technology, multi-jet fusion technology, which comparable with the injection molding process parts. So HP fusion 3D printing process. This is a voxel technology. So people can ask about the voxel. What is a voxel? So voxel is a volumetric of the 2D pixel. The similar like the volumetric of the pixel using for the 3D printing technology. So HP have a very large numbers of patent of this voxel technology, because HP last more since decades they have a lots of patent of the printing technology. So this is a voxel technology. They drop the fusing agent and detailing agent. So fuse the powder particle, make a solid. Again, they do the again fusing, and part can be reading. This is a completely fusing. So I will show the video so people can aware how this technology works. So printing system, energy apply here. So you see the video first and see how this multi-jet printing. This is a material actually. This fusing agent. Detailing agent actually, the detailing agent create the boundary of the surface of the part. So due to this, the rest of the powder can be reused again. So that's why part cost becoming cheaper because the rest of the material can be used the next build. So just so how this technology works, I will show the another video in my in this presentation. So we have a printing head, and each printing head have a 5,000 nozzles. So this three printing head have a 15,000 of nozzle, and with help of the agents is the completely fuse the powder particle and make it solid, which is a comparable with the injected molded part. So this a 2.8 meter wide thermal inkjet digital printing. Just how this is a size, no limitation with the printing technology. Currently, HP 3D printing technology multi-jet fusion machine have an area of the 380 into 280 into 380, which can completely volume can be print, not the one part or two part. You can stack there the several part, which I will show in my next slide. So there is no limitation of the area. You can print anything. The voxel by voxel control, you see just one image why this how this voxel control is doing in this image. Most of the 3D printers, they actually not printing image very good, not clearly, but HP have a technology which print the complete image with the very clear features. Due to this voxel technology is coming a very clear picture. So almost you can print the pictures, you can print the label, you can print the barcode also. So any kinds of the detailing features you can print along with your part. So people can technology can give the complete information of the 3D printer part, which can readable through the mobile application and can store the any numbers, any kinds, any details, text in this. You can store the data on your part. So this is a one unique solution HP having. I am here discussing about the technology. So how energy applying, they have a length, they have a fusing length, and the area they covering 900 points of the real time control with the closed loop layer by layer. So this 380, 280 and 380 area they covering with the 900 points. That's why they give a very good accuracy and resolution to print the part. So two fusing lamp in the east side of the printing cartridge, melting and finishing after each cartridge pass, taking the same time printing a layer full of the gears than a layer with the one gears. So this technology is going a radiant energy, fusing agent, and the radiant energy melting and fuse completely. So just show you some structure how this and have this technology MGF technology have a real-time control system with monitoring completely again generating the feedback mechanism, and it automatically correct by the software and mechatronics while the printing. So that's why it's not a fall or any problem happening during the printing, and parts can give the completely as comparable with the injected molded part with the good finishing, good strength, and iso property is the nature of the part. I think you are aware most of the 3D printing technology, the printing a part is have a porosity in the Z axis. XY is the okay, but Z axis when you can put the load, it can be break because the layer by layer addition they create there the porosity. But the HP 3D printing technology is not create a porosity in the Z axis. Is the similar in the all direction X Y Z is the isotropic by nature. That's why it is give the functional strength quality, and it's a fluid and airtight, which is the IP67 grade, production grade. So see that video how this technology works. This is a build unit actually, and this is a cartridge. This is a cartridge. Is doing all this making the build automatically. So after fill the build, they just put inside the printer and start the printing. So after finish the printing job, again remove the build unit and for the fast cooling, and the next printing can be a start. So after the unpack, they have to do the bead blasting. So material which is stuck with the part, it can be clear and then can be used for the your further process. So just you see how this technology works. So I think you are already aware about the technology. We have this machine in our facility at Noida. So anybody from a, NIT or any other college or faculty or a student who want to see the live demo of the physical machine, you want to do some research, you want to do some make a your proto or device or the functional part and your project, so you can so most welcome, you can visit any time. We can help you in this regard. So HP have a portfolio, see the a smaller machine to bigger machine, for the desktop series to production series. So we have a this 500 series, then 4200 series, then 5200 series, and 5210 series. So this is a technical detail, so maybe if somebody need, I can send them this detail later on. So this is the HP desktop series, a color 3D printing technology. So with strength, the HP can deliver the color part, the true color, completely CMYK true color part can the print, and the can be able to print the 16 millions of the color at a time. So 16 millions of the color combination can be print at a time. So this is a show the capability of the technology, and with strength So people can use this part for the any kinds of the making the miniature or the medical uh, surgical planning devices, equipment, or for the surgical planning, jigs fixtures, toys, presentation model, labels, and personalized prosthetics. So nowadays is the very demanding the prosthetics and medical application with the color. So HP multi-jet fusion technology can meet this requirement. So about the material, most of the people thinking when they're going to buy the printer or use the printer, they're getting the material with the machine supplier only. But here HP democratized the complete the system, and they develop material through the Archem, BSF, Ebonic, Henkel, all Lubrizol, all polymers, around 50 polymers manufacturer across the globe. They're making a material, the nylon powder or the TPU or PP, polypropylene or the any other powder. They're doing the research also for the HP multi-jet fusion technology. So people who want to just have the buy the machine, he doesn't depend on the supplier only. He can get the material in the open market from any polymer manufacturer like BSF, Lubrizol, Evonik, Henkel, Archem, just behind the your uh, facility. So this is a material roadmap. So high performing material, they have a polyamide family, elastomer, the TPU material they just launched. They have a PA12, they have a PA11, and the polypropylene and the PA12 with the glass bead, and the flame redundant material, FR grade material. HP also they innovated. They're going to launch the next month, so it will be very good for the aero application also, and some application where the flame redundant material needed. So all kinds of solution have under the roof of the HP. So just I'm like to introduce nowadays a very popular innovation is going with the most of the startup in the drone and UAV, and government of India also taking the initiative to give the provide the support to the startup, and some company and the student and the researcher to the research around the drone and UAV to fulfill the requirement of the Indian defense sector, and also it can do the export across the globe. So now I'm going to show some samples, actually the case study for the drone manufacturing and UAV manufacturing and healthcare. So how this HP multi-jet fusion technology people are using from these sectors. So challenges for today industrial drone manufacturing: payload vs the drone weight, battery capacity, customize and individualization, lead time, legal limitation, and cost and quality. So this is the challenges now this drone and UAV manufacturing facing. So the lead time one of the area, and also the cost and quality. So when you're going to making the drone and UAV, the people don't have a 1 lakh and 2 lakh like automotive. That doesn't have a order, or the requirement is the very large. They have a very limited like 100 pieces and 200 pieces and maybe the 1,000 or 2,000. So for this quantity, when they go for the die and mold facility, it take a lots of time, which can not allow them to this time to make his project or object, because this competition scenario they need to do the very shorter timeline. So here is the 3D printing technology, and HP multi-jet fusion technology can help to reduce the lead time and capacity and strength of the parts. So my next slide, you see what actually we are doing. So application where HP multi-jet fusion technology make this complete body, cameras, casing, electronic casing, payloads, complete this made by the HP multi-jet fusion on the material PA12 nylon with the high loaded parts. So you see, and somewhere they needed some more stuff. You can print on the PA11 also. For the flexible, you can print on the TPU, uh, the flexible thermoplastic. All thermoplastic HP multi-jet fusion are using a completely engineering grade thermoplastic. So let's talk about your application like surveillance, agriculture, farm, policy, medical support, real estate, moving and journalism, oil gas, insurance, construction. So this is an area where multi-jet fusion or any kinds of the 3D printed technology can work and give them help to develop their project and object in the very shorter time with a strength and is go for the market also. So potential application for the drones actually polite base, engine brackets, sensor bracket, cover and sails, and landing gears. So these are made by the some of company. You know, India also most of the company using most of the drone and UAV manufacturer now they are getting a parts from HP multi-jet fusion technology. And now this market is growing very fast. I think the most of the researcher, your PhD student or faculty know this area is the very key area is nowadays which going to is the catering through the 3D printing technology, additive manufacturing technology. This complete house body part actually is made on overnight. Minimum structure weight, maximum flight range. So you see the drone application main structure. So this structure actually made through, you see this here where my pointer is this made on the HP multi-jet fusion technology. So this structure completes it. And people are flying this drone air UAV now and also supplying to the military, defense, agriculture, anywhere is needed. Camera casing, this is application. Bring complex design into shape within a 24 hours. So a design, if you have a design, you will get the part maybe within a next days. Optimize cost and scale up production with the MJF technology. Print multiple parts at once by nesting the full build chamber in the 380, 280, and 380. So you not a one part, you can stack the multiple part together and print the complete volume. You see this picture. And not a one design to consent. You print the any design, like you have a 15 design which come in this area 380, 284 and 380. You can print this all 15 different design the one time. So this is a freedom having with the this multi-jet technology. No cost for the support removal because they're using a powder. So powder become a support itself, and after printing, you can remove the powder very easily through the brush or just powder removal is a very easy and no addition cost for the tooling. So here also people can save the tooling cost, die cost, and the time. So this is the advantage we have in the nowadays with the 3D printing technology. Case study Eldroad UAV unmanned vehicles. So you see this a very looks a very funny. The main challenges for the Eldroad project was to make the large scale drone that was a light, reduce and resistance. In addition, we need to cover the maximum internal space of the drone into a useful volume without geoparalyzing the integrity of the drone. So previous area, the original idea of the manufacturer, the prototypes was that through revis wood and the carbon fiber would be used since these material are light and resistant. So the technology nowadays, the DFM is a very popular. So you can do the DFM design for the additive manufacturing. You can reduce the area where not needed, and without compromising of the strength, you can print, make the hollowing, make the different structure, and you can save the time, save the material, save the cost, and also save the weight. So now 3D printing giving the freedom to work unlimited. After a long period of construction feasibility problems, HP offers the opportunity to print the drone with the maintain the faster way to increase the initial design, the structure visibility, precise the aerodynamics surface, and the reason why SP prints 90% of the printhead model, the prototypes of the 4 meters. So not the limitation of the size. You can print, you can create the different structure, joining a structure, and you can print the large part also, the 4 meter, 5 meter. Recently, we have experienced the print the complete the Brezza bumper. It's at 18 feet. So we have these kinds of the case study also to with print in our facility only. Drone production on demand. So now is the very demanding using the multi-jet fusion technology in the produce the non-standard drone part, offering them to their customer on demand. So why HP? You have another also. But why HP? Because the decision to use the HP multi-jet the resulted from the design to produce a strong and light functional part in the full color from the PA2L material. Without the needed die printouts, the production of custom component is also much faster than when using the other 3D printing technology, not to mention CNC machining or the injection molding process. So people are hearing me? Hello? Yeah, if hearing me, you have any question you can ask?
Yes, sir. Yes, sir. We are hearing you. We will be having the questionnaire session at the end of the session. So
Okay.
whenever
So
you will be
now I'm
finishing,
just
then
show you video drone actually which manufactured through the help of the 3D printing only. So here I just showing you some example. HP multi-jet manufacturing course example is a 3D high usability PHUM. So you see this, I show Wing connector components, €496 is the area. This connector area is at 271 mm, 25 mm in the Y area, and here to here, and 35 mm is the height. So completely is the 28.8 centimeter cubic centimeter this area. And in the one build, the HP multi-jet fusion technology is printed 180 parts per build with 15% packing density. You see this sensor is the area is the 115 into 109 into 127. So completely 22.1 centimeter cubic centimeter. So 117 part print at a time. The locking connector, you see 16 mm into 15 mm into 20 mm X, Y, and Z. So it's print 3000 part per build. So just I am showing this how this manage the short batch production, and your people can manage their production with the multi-jet fusion technology. So it can be produced the more part with a very limited periods. Just showing here the the economics to printing. The material, so we have a PA11, PA12, and TPU. The TPU actually is developed by the BSF, and people can directly buy from BSF or HP or us from Adroitec anywhere. Multi-purpose TPU material. So this material capability we have recently launched PP also, polypropylene, which is the engineering grade thermoplastic using for the automotive industry last more than a decade. So you see the lead time of these parts, 18 to 12 weeks. 18 to 12 week, and the high tool investment for the 30 to 100. High productivity once tool is running, most external manufacturing and aborts. So with the HP multi-jet fusion technology, lead time is a matter to the days, maybe the 1 day or 2 days, and not a week. And no tool investment there, high flexibility, in-house manufacturing. So the idea of the complex component with a short lead and quantities below 50,000 parts. The injected mold, basically the idea for the above than 15,000 parts, maybe there were lakh and 2 lakh and the millions, injected molded process is the suited. But below than the 50,000 requirement of the any part, people can use the multi-jet fusion technology. It is similar for the injected molded part. So that's all the same, the shorter lead time, cost per part, inclusion of the multiple components, technology pioneer, prestige, and contents quality of the components. So this is the reason why internal manufacturing and people are preferring. Reason for the external manufacturing, only few component or a small volume, quality component not critical, and lead time is not critical. This is a internal or external, why people are choosing to do their make their product of the outside or inside. So this, so the actually the multi-jet fusion industrial drones, why they using multi-jet fusion technology, because of the accuracy is give a very unique accuracy, design freedom, low limitation. You can use and print any kinds of design which you have in the mind, and the breakthrough productivity is also higher. Material performance, we have a very engineering grade thermoplastic and best in class economics. So all these key playing to actually make this technology very unique. So now I am coming the healthcare area. This is a very also good area, very emerging area where can 3D printing or additive manufacturing technology can applicable. So you see these pictures, the complete for the head to foot, all requirement of the prosthetics or orthotics is can be printed. So this is a possibility I am showing, and also actually also the requirement need actually nowadays people are using this across the globe, prosthetics and orthotics which printed using by the 3D printing technology. So I'm coming the insole. So all people wearing the footwear, insole. When you're going to check your foot, I ensuring everybody have a plus minus or their left and right foot. Maybe the 2 mm, 3 mm, 1 mm. If you scan your part, you get the complete idea how this foot you're having the different. So this foot is the make a some issue during wearing a shoe. People are actually don't have a, actually mind these kinds of problem, but when become some illness and some kinds of issue in their of a foot area, it just feel how this problem they are feeling the wearing the shoe. They got the pain something, and maybe you cannot sustain a very long time shoe with your foot. So now there is a solution called the flat-footed solution, diabetic foot solution, and the foot correction the using by the 3D printing technology, and HP playing the very big role there. So instead of the plaster when the fractures by the hand or foot, people are using this 3D printers, these kinds of brackets. And this you saw where my cursor is there. This is ONP is using by the healthcare industry for making the food correction. So now a startup have a business model also. They're making a diabetic food or the flat-footed solution and providing this solution to the customer, and people are very happy with this solution. So orthotic insole, orthotic brakes and deforms, clinical orthotics, prosthetic sockets, and prosthetics figuring. So these kinds of the healthcare solution now people are using through the 3D printing technology because it's not a very mass produced value, not a common actually, not a like consumable item. This is a customized. So complete customization can be done on the using the 3D printing technology for the area of the healthcare, prosthetics and orthotics. So insole market, just have a market overview how this market is supply chain is running there. So like a sports solution have a running food and diabetics, redeform, slim and dress, and this market scenario how this going on just so in this flow chart. I'm coming the complete supply chain how this working. The first people have a CAD/CAM solution. They doing their the complete designing and surface modeling or their prosthetic after scanning, and they do the printing. They have a manual process. They actually manual process. People are taking your impression of the food, and they making their negative to positive through the they pouring their the ceramic, some kinds of ceramic, and this is a very lengthy process. But now that nowadays through the help of the scanner, they got the exact image of the food or the any kind of customization or from the MRI, and they do the complete modeling through the mimic software from materialize and then can be printed on the SP multi-jet fusion technology, because they using a nylon powder with the food grade material. It can be not have any toxicity with the close content of the skin. It cannot implant inside the body, but it can wearing through the close content of the skin is a don't have any toxicity. So that's why nowadays medical industry is also uh, accepting this technology very faster. So just I am showing this flow chart how this area moving now is the very fast. So dental, this is a very unique area is the dental. People are I think most of the people aware about the aligner, clear aligner. So when you have a issue in teeth and teeth correction, so as I think now most of the dental hospital, they using a braces. So nowadays, dental industry using this complete transparent aligners, and it can be making the very faster to correct the teeth. Somebody have a teeth out of the mouth, and this corrected by this help of the aligner. So nowadays medical industry using this, and I think AIMS also doing this kinds of the solution, and they providing to the patient nowadays. So people have, they needed a teeth correction, he can go to the AIMS, and nowadays they providing this solution through the help of the 3D printing. They printing complete model and do the vacuum forming with the transparent aligners, and they fit in the patient teeth. And after actually the braces, through the braces it take around 15 to 18 months, and through this technology, the help of the 3D printing, it can be correct within a 6 to 8 months. So this is the advantage now medical dental industry getting through the help of the 3D printing technology. So this see how this market is growing, and have a estimation from the 2014 to 2024. Clear dental analyzer has been available on the market over 20 years. It's estimated that currently the majority of the clear dental aligners are produced using the 3D printing molds. Predominantly resin-based 3D printing technologies such as stereolithography, SLS, polyjet, and the material jet are being used in production. In the 2017, it was estimated that over 80 million units were printed. The forecast, as the figure is showing here, the predict a steady increase in production over next 5 years. So how you see this market is growing now from year by year, because they give the correct solution with the very limited time, and also this is not a very actually this is a very hassle free solution, not a critical. Do not patient cannot feel, patient is feel very easy to using the clear aligners. How clear aligners made actually? So just just giving the flow actually. You see that this is the doctor give the impression when the patient go to the doctors, they take the impression through the silicon kinds of the material, and the dental lab do the scanning, that do the software modeling, as same kind of the reverse engineering process they're doing through the dental industry also, and printed on the 3D printer, the polymer, and after this printing this model, they do the vacuum forming. So this plastic transparent sheet they making through the help of the vacuum forming devices, and after the making this aligners, doctor put this the patient teeth for the teeth correction user. So this is the flow chart. Is the work process is going on of the through the dental industry. So one customer in the USA, they have a 50 3D printing HP multi-jet fusion technology. They're making millions of aligner and producing this technology. They're also exporting to the Europe and India and other countries where needed. And the Smile Dents, the name of the company. So this is actually forming is going on. So after printing this model, it can be do the forming through the help of the thermofolding machine. So now I just this presentation is over. So just I requesting if you have some question, please you can start the questions answers.
Thank you, Pandey sir. It was a nice informative talk. You have covered all the related aspect related to your 3D printing business, and you also covered the market scenario, whatever the market scenario nowadays. And we have few questions from our participants. So the first question is from Professor Balram Day. So he's asking about MGF technology. I think actually he didn't mention the technology. He might be asking about MGF technology. So he's asking, can it withstand with jet engine high temperature?
Jet engine?
High temperature, like engine components.
No, engine component cannot made in the plastic. Mostly engine component is the made by the metal.
So he might be asking like in future will there be the metal technology?
Yeah. Nowadays, engine component is the jet fuel nozzle is making by the GE Aviation, and they using this for the jet engine. This fuel nozzle. So HP also going to launch the metal 3D printing in next year, and it can be made the engine components because it's the completely the technology for the production series, not for the prototype. And the metal also they're going to launch the same production series 3D printer.
Sir, another question is from another participant. He's asking what makes HP different from SLS technology?
So actually SLS is the just using by the prototype, not for the final production, because they have a porosity. You cannot pass the fluid and air through their printed part. HP 3D printed part is the isotropic by nature in the X, Y, and Z all three direction. SLS technology printed part is the porosity in Z axis. So when people can put the load, it can be break. HP is doesn't a similar load. If you put the both printed part, HP can sustain because of the strength of the material, strength of the direction is the all is the three direction is the same. And this is
Thank
a
you, sir.
fluid tied. This is a fluid tied part. MGF printed part is the fluid tied and air tied, and the SLS printed part is not a fluid tied and air tied. If people can pass the fluid or air, it can be leak.
Thank you, sir, for such a nice elaborative answer. We have another question from one of our participant. Our main preference in research, actually we are belongs to teaching environment, so our preference would be research. And what are the key areas to write research paper in additive manufacturing?
Research area, additive manufacturing have a lots of key area to do the research. The orientation of the part, the resolution of how resolution, every part have you can print the different resolution, different orientation, and the material, different material, and you do the all kinds of the mechanical and chemical analysis. So 3D printing, this additive manufacturing has a very wide area to do the research, because this is a new technology and it also need to proven to the industry. So that's why I have a lots of.
Thank you, sir. There is another question. There is another question from one more participant. What kind of materials we can use in bio 3D printing? Is there a possibility to use HP components into biological applications?
Actually, depend if you want to do the print the biological application, you can print. But HP 3D printed or any HP 3D printed part, you cannot implant inside the body. So nowadays the bio 3D printing technology mostly using printing the liquid actually tissue engineering. Most of the people doing the research around the tissue engineering only, which can be done by the gel kinds of the material, biogels like LG-NET and different kinds of the biogel, PCL material, the bone kinds of the property material. So the HP also doing the innovation to print the bone kinds of the material. So maybe this is the future task. But currently that you can print any kinds of the biological model through the help of the HP 3D printing technology within the color. So it can be show the complete color which you have in your MRI data.
Next question is, sir, there are several multiple questions, but there are some repeatable questions, and there is another question which I have found, which is different. As per you, which is the most versatile technology in additive manufacturing?
Versatile means what they actually all additive manufacturing in itself is a versatile technology. But
they are talking about, sir, which can stand with majority of applications.
Majority of application can the any powder bed technology can be catered because they doesn't need a support. And HP 3D printing technology can do the prototype, it can be used for the research, it can be used for the functional fitment, and it can use for the final on-demand part. So this is a completely versatile technology which can tackle the all area which needed for the requirement of the manufacturing to modeling to designing and everything. Proto to complete the functional. So it can be cater the all area.
I hope all the questions has been answered. There are some repetitions in the questions, so we are not taking much, and there are a lot of questions we are still receiving, but all of them are looking to be repeatable. So thank you so much, sir, for your valuable time, for giving this such a wonderful talk, and we wish we will have you soon with further more FDPs to present such a knowledgeable talk again.
So thank you. So and I
thank you so much, sir.
Opportunity to interact with you. If anybody, if a participant have a need some any special question or they need some detail, he can mail me and he can also come through the NIT